All right, so exam to review. All right, so the first couple of questions on here aren't too bad. Of course, there's more questions on the review than there is on the actual exam, I think. So the first one, number one, it's pretty straightforward. If you try this exam out, you'll see it's pretty basic, right? So square root 2 over 2. They ask you find the exact value in radians. So basically, you look at the unit circles, right, and figure out what angle gives me a square root 2 over 2, right? So you can change this into using the definition and say what theta, right, gives me a square root 2 over 2. The same question, these two questions. The theta would be pi over 4. Right? There's not much to do here. You could use your calculator for some of these guys. These are basic angles. You don't really need to. So you could do sine inverse square root 2 over 2, which is 45 degrees, right? So pi over 4. All right, let's keep on going because I don't want to spend too much time on the easier questions. Let's move on to find the inverse of a function. So this is number 1, 2, 3, 4, number 4. And then, okay. So this guy says find the inverse function f inverse of the function f. Okay, so here's the function 5 cosine x plus 9. Remember how I gave you those couple of steps on how to do this? So step 1, we said change f of x into y. So y equals 5 cosine x plus 9, right? Step 1. Step 2, maybe I should circle them because it looks like some questions. 1, 2. We said switch x and y. Okay, there we go. X equals 5 cosine y plus 9. Step 3, solve for y using inverse functions, right? So we did. So we do cosine inverse of both sides. Oh, actually, sorry, not yet. Getting ahead of myself. First, you isolate cosine, and then you introduce inverse. You cannot just do it right away. So we're starting right here. So I'm going to subtract the 9. Divide by 5. Right. I need to so too many algebra steps. I'm sure you guys know how to isolate cosine rate. So then we end up with this guy. So now at this point, you introduce inverse cosine. So inverse cosine of both sides will cancel this cosine. Okay. So now the final step, I guess we should write that as a step, is just to rename the question or the y. Change y into f inverse. So the final answer will be this guy. Okay. And that's going to be C. That's question part C. Okay. Are there any questions on finding inverses of trig functions? Okay. Let's keep going. Let me know if there's any questions at any point where something doesn't make sense. This is question, the fifth question. For cosine inverse of x equals pi. All right, so here we just introduced the cosine function to cancel cosine inverse. So the question is find the exact value for x. So solve this equation and get an exact number. We do not want the calculator answer. So you would divide by 4 on both sides, right? And isolate cosine, kind of like we did earlier. Okay. So then you get cosine inverse of x equals to pi over 4. Which technically could be rewritten as cosine of pi over 4 is equal to some x. They want to know what x that is. But if you use the inverse idea, you do cosine of both sides instead of the definition. And then these will cancel, right? Leaving you with x is equal to cosine. This is the same deal, right? Which is going to be square root 2 over 2. So this is B from the review. Do you have any questions on 5? Okay. Let's try 6. This one is kind of hard. Find the exact value. Write the instructions this time. Tangent of cosine inverse -1/2. Okay. So remember when we did these, we said look at the inverse part, or deal with this inverse part and build a triangle. Since it wants an exact value, you don't want to use calculator on this question. So you'll build a triangle based on this inside part. And once that's built, you will find the definition of tangent based off the triangle. Remember, tangent is opposite of adjacent, right? So you look at this guy and say, well, some theta exists for this value, right? So the definition is that there's some cosine theta. I'll write it over here. That's the way we've been doing it. There's some cosine theta equal to -1/2. Okay. No. They did not mention anything about quadrants, but that's all right. Cosine inverse is usually defined between the top half of the circle, quadrant 1 and 2. Cosine is negative in quadrant 2, so I'm going to make the assumption that this is all quadrant 2. Okay, so let's build our triangle here. So hypotenuse, -1 value here. Find the Pythagorean theorem side here. So some scratch work over here. So this would be 2 squared -1 squared plus b squared. B is equal to the square root of 4 minus 1. So, yeah, we probably should have known that already, but it's all right. Might as well do our work, right? So now the question becomes, what is tangent? Tangent of this theta, assuming this is theta here, that's the assumption that I made. Tangent using this information will equal opposite over adjacent. So √3 over -1. And that is answer A. You guys have any questions on part 6? And just FYI, hypotenuse is never negative, so it's either going to be one of these. That's why I put it here, if you're wondering. Because cosine was negative, but it did not distinguish where the negative goes. But you'd never put it on hypotenuse. Anyway.
So rewrite the inverse, do a triangle, and then find the tangent.
Yeah, exactly. That's what this, whenever you see this, is basically telling you find tangent based on this info. And this info can be translated using the definition here. The rest is just for space. You guys are cool. You guys understand Pythagorean at this point. I don't need that. Either way, I'll post the video. It doesn't matter. All right, so number 7. Okay. One moment, please. All right. Number 7 is find the exact value. Same question. Different problem. Find the exact value of cosecant inverse of -2. Okay. Now, what is the reciprocal of cosecant?
Sine.
Yeah, it's going to be sine, right? So cosecant inverse of 2, or -2, is really the same question as sine inverse of the -half. And sine inverse is defined between quadrant 1 and quadrant 4, the right half of the unit circle. So this is going to have to give us a negative angle because negative y happens in quadrant 4, right? Not quadrant 1. So this should be a negative pi over 6. Based on the circle. Here, let me pull up the circle in case that's not enough info. Okay, here it is. So remember, sine inverse is defined on this side, just like tangent inverse. So it's gonna, if it wants a -half, it's forced by definition to go down here. So it's gonna find this value, this angle here. So to remain in the domain, it will give you the negative angle, not the positive. So it has to go -pi6 this direction. Okay. Now, you could technically use your calculator on that guy. Sine inverse of -0.5, right? That's -30 degrees, which is -pi6. So the answer choices are choices. Look at it real quick. Looks like, yeah, cosine inverse, yeah, -pi6. Okay. In other words, -30 degrees. So technically, you could have used your calculator here because it's a known angle. If it was not on the circle, then you couldn't. Right? Okay. You ready? Oh, this is our radians. 1 second. Let me switch to radians for the next question. Yeah, okay. So question 8. Let's use a calculator. So this time you'll have a decimal to find the expression in radians rounded to 2 decimal places. All right, so here's the question. Cotangent inverse of 10 over 29. So what you do is change it to tangent, because that's what we have in our calculator, right? Of 29 over 10. So at that point, you just punch it in your machine. Just make sure the machine is in radians in your scientific calculator, right? So that'll be second tangent inverse of 29 over 10. Let's see if this works. 1.238. Yeah, their answer was 1.24. So that's all you have to do for pretty much 6, 7, and 8 is just punch it into your calculator, really. But you do need to know this fact that if you convert to the reciprocal, you need to flip the angle itself, or the value inside. Okay.
Can we see your calculator?
Yep. I'm curious. Let me do it the other way. No, it doesn't work that way. Well, it's about 1.4. Or 24, sorry. Okay. Next question, number 9. Write the trig expression as an algebraic in U. Okay, sorry, got distracted there for a second. So this is similar to number 6, except it's in general terms, right? So use a definition for sine inverse of U. That means, right, that there's some theta that will give you U. Okay, so using the definition of the triangle for sine, if I put theta right there, U will be opposite, 1 will be the hypotenuse. Using our Pythagorean theorem, this side will be square root 1 minus U squared. Yeah, that's right. So cosine of theta will equal this over that. So 1 minus U squared over 1. Okay, not on camera. So cosine theta adjacent over hypotenuse. So of course it's just this. Oh man. All right. Any questions on number 9? Okay. Okay. Then solve the equation. On this interval 0 to 2 pi. Okay. Well, minus sine theta equals to half. Sorry, I got confused there. All right, so I'm going to subtract the 1 over. That'll give us a negative half. And then divide by negative, which makes this a positive half. Okay. So if we do this in degrees, just to get a sense of this, where's my radian thing? The sine theta is equal to half at 1/2 at the pi 6, right? Or 30 degrees. And 5 pi 6 or 150. So this will be, the theta will equal they use radians in the question, sorry about that. So I'm going to change this to pi over 6 and 5 pi over 6. But I believe in the notes we said, all you have to do is use your calculator here, and then you find the, you subtract from 180 to find the other guy. Okay, so 180 minus pi, or pi minus pi 6 will give you this guy. Okay. So if we did not use a circle, let me switch back just for memory's sake. For sine, let's say you didn't know how to find them. You say, let me use sine inverse on both sides. Okay. So theta is equal to what our calculator says, even though we know the answer. Let's just go ahead and use it. Change it back to degrees though. Second sine 0.5 will be 30 degrees. So that's the first one, right? Pi 6. To find the other one, you would say 180 minus 30, which is 150, which are these answers here. In fact, if you were to do it with a calculator, so for without a unit circle, that's how you do it. Okay. Let's take a short break here. It's 6:47. Let's come back around 7. Okay, let's get back to it. Now, number 10, we are on 11. Okay, there. Okay, so next question says use a calculator to solve the equation on 0 to 2 pi, round to 2 decimals. places. All right, so the question is tangent theta is equal to 4.8. So for tangent, it's a little bit different than the sine inverse we did earlier. We did up here. See how we did 180 minus 30? So on this guy, we will do tangent inverse, so similar start, both sides. And then we cancel those two, so theta is equal to, let's do this on our calculator. The answers are in radians, even though they don't mention in this question. They should have, but letting you know right now when you do this yourself. So tangent inverse of 4.8 is 1.36, so we will round to 1.37. So to find the other angle, what you do is take the 1.37 and add pi. So just add the previous answer, add pi to it. That is approximately 4.51. Okay, so for tangent, you do not subtract from 188, you add pi to it. Although the other question, you could have used the unit circle. This one you could not. So hence the what's it called? Calculator requirement. Our next guy, cosine squared of theta minus 1 is equal to 0. So isolate the cosine, and then here we will use the square root property. So square root both sides, right? So when you square root, you have to tack on the plus or minus. You don't have to do it to the left-hand side because it's already squared, plus it only needs to be on one side. Now the question becomes, where is theta, or where is cosine theta equal to -1 or +1, right? So technically we have two equations here. Cosine theta equals 1, cosine theta equals -1. So these can be easily found on your circle, so that's 0, and that is pi. Any questions on 11 or 12? Okay. The next one is the weird one I was thinking about earlier. Solve. They have all been pretty much, well, sorry. 10 and 12 are solved. I just didn't write it on 12. Solve the equation on 0 to 2 pi. So tangent of theta plus secant of theta is equal to 1. So what's easier to think of is to change this to sine and cosine. So that would be sine theta over cosine theta for tangent, and secant will be 1 over cosine, right? Which means we can add these together because we already have the LCD. So that would be sine theta plus 1 over cosine theta. Now you can multiply both sides by cosine, which will get us to here. Sine theta plus 1 equals to cosine. Let's skip the minor algebra step. You guys cool with here to here? Does that make sense? All right. This one it got weird for me anyway. So I'm like, okay, which angles will make this true? There's not very many. So I'm like, okay, if I choose 0, say I let theta equals 0, that would give me 0 plus 1 is equal to 1, which gives me equality. So that's the first answer. And the other one would be, let's see here, if there is another one. No, there is not. There is not another one. That's it. But honestly, what bothers me is I'm kind of using, I feel like I'm cheating, honestly. Because yeah, I can kind of brute force my way through it, but I don't think that's legit math. So let's try a different approach compared to the other approaches require higher level math, and we're not going to do that. Something we can do though is graph them, right? We can technically say, all right, well, if I graph both of these functions, the left-hand side, treat that as one function because that's kind of what's happening. I'm going to use x just for simplicity. And go to the next one and say, all right, well, cosine x. So when are they equal, right? In other words, when do they intersect between the interval that they requested? 2 pi is 0 to 2 pi, so that's what? Times x, so they intersect here, and there. So at this point, let me double check it. Yeah, so look at there's 3 answers, or at least 2. So let's check our, oh, actually, this is interesting. There's a reason I can't use this guy here, because the original question was what? Let's turn these off right for now. The original was tangent plus secant equals 1, right? So let's say I graph the tangent and then 1 minus secant instead. That's technically the same thing. Notice how they do intersect at 0, the original question. And if you're wondering where the hell that came from, right, let's look at the problem. If I move secant over here, similar to what we have there, I can do another graph. Okay, we'll go back here. This graph, though, does not include the 3 pi halves, 3 pi over 2. You see that? They don't intersect again. So the original equation does not intersect again. The one that I created intersects twice within the interval they asked for. Yet they should be the same, right? Yeah, the issue is because, if you look back to the original question, why it has to be only 0, is because if I choose 3 pi over 2, I will get division by 0 on the original question. I manipulated it to turn into this, thinking this would be easier to solve, and it was, but this gave me kind of like the illusion that 3 pi over 2 is okay, but it's not. 3 pi over 2, 3 pi over 2 is right there. Yeah. No, see how that should work. 1 second. 3 pi over 2 would be 0 for cosine, 0 for sine. Doesn't make sense. If the y goes in front, I'm confusing myself. Oh, right. Yeah. 3 pi over 2 would be 0 for cosine. 3 pi over 2 for sine would be -1. So yeah, you would get this equality. So technically it works for this equation that I made. But it does not work for the original because it gets division by 0. So I need to stick with the original when it comes to solving these guys. If you use something that you created, you need to remember what was restricted. Cosine cannot be 0. So I cannot use anything that makes cosine 0. why I chose only this answer. So I think graphing is a better approach, but you can kind of brute force that thing. All right, let's go to the next question. Okay. What was that? Okay. Number 14. So this guy just says simplify. Cosine theta over 1 plus sine theta plus tangent theta. So they want me to simplify. They're not really telling me to solve anything. I'm not proving an identity or establishing an identity. Just simplify it. So basically, you combine fractions, cancel stuff, that kind of deal. So currently, I don't see anything easy to do. So I'm going to start with just trying something. I currently don't know how to do this, but I'm going to try stuff. That's how I approach the proofs and identities. You just got to try something. So from experience, I know that usually you should start by trying to add fractions and see if something simplifies or combines using your identities. So right now I notice that there's an LCD of 1 plus sine and cosine. So I need to introduce the cosine to that first fraction and the 1 plus sine theta to the second fraction. So here we go. So the first guy here, and there it is. The next one. Missing piece that this guy needs. Get the LCD going. The top will become cosine squared theta over the LCD, which I'll leave like this for now. So I don't want to multiply in case I see something that cancels. I will distribute the sign up here. Sine theta plus sine squared theta over that LCD right there. Cosine 1 plus sine. There we go. So now they have the same denominator, so I can go ahead and add them. Cosine squared plus sine theta plus sine squared theta. Okay. Down here, I just have the LCD. Now we know that. So here to here, I'm just adding fractions. Now we know that cosine squared plus sine squared is 1, right? That's your Pythagorean identity. So we get 1 plus sine theta over 1 plus sine theta cosine theta. From here to here, we use the Pythagorean identity. right? Sine squared theta plus cosine squared theta is 1. Now, notice how these are all multiplied, so I can cancel these, leaving me with 1 over cosine. So that will simplify to secant, which is answer C. So simplify all that nonsense is the top original question, which is a weird way to write secant. Are there any questions on this problem? So the next one now. I'll get a new page for this one. This is number 15. This is establish or prove, basically, the identity. So it says secant theta minus 1 over tangent theta is equal to tangent theta over secant theta plus 1. All right. So we gotta choose a side, and then we gotta prove the other side, or get to the other side. Currently, I don't see, they both seem pretty equal, so I'm gonna choose the left-hand side, I guess, just for no reason. Then I see a secant theta minus 1, so I'm thinking maybe a conjugate approach might help, and see if it does. So the first thing I'm gonna do is multiply both sides by secant theta plus 1, the conjugate of the numerator, which will give us secant squared theta minus 1, which is the difference of squares. Once you FOIL all that out, you get this. On the bottom, I will leave it this way. Now, secant squared minus 1 is an identity, right? Here to here. Multiply by the conjugate. You guys remember what secant squared minus 1 is?
So just tangent squared?
Yeah, I believe so. Let's check. Cosine squared plus sine squared x, or theta, whatever, 1. If I divide all sides by cosine, I will get 1 plus tangent squared equal to secant squared. If I subtract the 1 over, that's right. Yeah, no, for sure, it is. So the top is actually tangent squared theta when you use the Pythagorean. Let me write that better on the side there. I don't have the formulas in front of me, so I just wanted to double check that. So here to here, Pythagorean identity. Secant squared theta minus 1 is equal to tangent squared theta. Okay. All right, so then we can cancel one of those tangents, right? So we'll be left with tangent theta over secant theta plus 1, which is what we wanted to show. That was just algebra, right? Nothing special, right? Any questions about this problem? Okay. Find the exact value of the expression tangent of pi 12. So there is no pi 12 on your unit circle. So use your half angle if you can spot it, because that is really just half of pi over 6, right? So we need the half angle formula for tangent to help us out here. I'm going to write that better so it looks correct. Okay. It still looks like crap, but whatever. Let's find the half angle formula. Oh, here it is. Okay, so there is a formula so that this can be equal to sine of the pi 6 over 1 plus cosine of pi 6. So what is pi 6? Well, it's about, what, 30 degrees, right? Let's check it out. So pi 6 is right there. So sine will be 1/2. So on top we got 1/2 over 1 plus square root 3 over 2. Okay. Not look pretty. Hold on a second. Maybe we can use a better formula. The sine, yeah, I think this is better. Let's scrap that. Remember how tangent, the half angle for tangent has 3 different forms. And did I give you the notes? So I'm gonna use a different form, so I don't have to deal with these fractions the way they are. That wasn't wrong, I'm just, that's easier to write. 1 minus cosine of pi over 6 over sine of pi over 6. So that would be 1 minus square root 3 over 2 over 1/2, right? Which would be the same as 2 times 1 minus this stuff which would then be 2 minus root 3. So that's way easier than the last one. So yeah, answer is D. Is there any questions on the 16 problem? All right, let's keep on going. Okay, 17 here. Use the information. Okay. Given about the angle. Theta. 0 is less theta, which is less 2 pi. I feel like there should not be a line there. Okay. Find the exact value cosecant theta is equal to 5/3, and theta is between pi halves and pi, which would tell us that it's in quadrant 2. Okay. Cosecant is the reciprocal of sine, so technically sine theta is equal to 3/5, right? Yeah. Okay. So let's make our triangle. Oops, I forgot what they want. They want us to find cosine 2 theta. But before we do anything, we need to build a triangle anyway. So opposites over adjacent. This will be 4, 3, 4, 5. Yeah. Okay. So cosine is negative in quadrant 2. That would be negative 4 over 5. Okay. So remember the double angle formula. Cosine 2 theta is equal to 2 sine. Oh, actually, there's 3 forms for double angle cosine. Let me look those up. You can use, well, now that I found all of them, it doesn't matter which one you use, but cosine 2 theta has this formula: cosine squared x, or theta, minus sine squared theta, or 1 minus 2 sine theta, sine squared, or 2 cosine squared theta minus 1. Okay, so I'm going to use, I guess the top one, since I have both already. So cosine 2 theta is equal to cosine squared theta minus sine squared theta. which would be -4/5 squared minus 3/5 squared, which is 16/25 minus 9/25, which would be 7/25. Which, let's check our answer. That will be answer D. Okay. Do you have any questions on 17? Sorry, got distracted again. All right, the next one is pretty much the same type of question, except they do a half ended. So I'm gonna skip that guy, go last two questions. Although I think the last two are pretty straightforward. Let's go ahead and do them though. 18, 19, sorry, 19. It says express the product as a sum containing only sines or cosines. This is the last thing we did. So here's cosine 3 theta. I think it was the last section in chapter 8. So we use the product of sums, right? So let me look those up real quick. Product to sum formulas. Here. So that would be equal to cosine cosine. So that would be 1/2 times cosine of 3 theta plus 2 theta plus cosine of 3 theta minus 2 theta using a formula from your notes. That should be a cosine of 5 theta plus cosine of theta. Is there any questions on 19? We're just using that formula. That is answer B. Last question, 20. Sine of 4 theta minus sine of 2 theta. The question is basically, let's express this sum or difference as a product. So we're going in reverse compared to 19. So product of sum formulas, let's see where I put those guys. Okay, so sine minus sine is going to be this one. So sine 4 theta minus sine 2 theta is equal to 2 cosine of 4 theta plus 2 theta over 2 times sine of 4 theta minus 2 theta over 2. So that will be,
I don't know if I copied it wrong, but my sine minus sine has two sine with
let me check.
theta plus theta.
Your sine minus sine, you got sine here?
Yeah, sine, and then the for the it's a negative on the first fraction and a positive on the second fraction. But yeah.
Are they both sine though?
Oh, I'm sorry. It's sine cosine. I just had it. It's the same thing. I just had it backward. I just wrote it backwards, I think.
Oh, okay. Yeah, it's the same deal. And it's not bad. It's not wrong either way. I just wrote it in reverse.
Oh, yeah. Okay, my bad. I confused me. Sorry.
Sorry about that. Yeah, I just pulled out a random formula sheet. It wasn't the same one I used during the lecture, so it was out of order compared to what we did. Sorry about that. But just remember, 2 times 3 is the same as 3 times 2. So we are able to switch them. So 4 minus 2 is 2 theta over 2. So our final answer will be 2 cosine 3 theta, sine theta, and that's it. All right. Do you have any questions on any of the problems we did today? Let's try and, I know I went a little fast, but I was trying to get them all down for you.
Yes, sir. For
One
question
thing I just did. Oh, sorry.
no, sir.
You can go first.
Okay, for question 19, I didn't see that as an answer option.
Let's check.
Yeah, I was gonna say for number 20, I got a different answer as well.
For 19, they got the correct answer is 1/2 cosine theta plus cosine 5 theta, which is the same as this. I just wrote them in reverse, right? So same deal. So this is the same. For 20, same deal. They also switched them.
Thank you.
So you can do another step just for fun. You can do sine theta if you want to match it up to the answer choices. Right. Same thing here. You can flip them because we know addition and multiplication commute, right? The commutative, so you can always write them backwards or forwards. Don't let that mess with your head. Any other questions? All right, guys. Don't forget I think I sent you a message about the extra credit it's due today. If you have not done it already, please do it today or tonight. Also sent you instructions in case it wasn't clear already on how to submit it. Yeah, okay. But I cannot extend the extra credit because I need to submit it to my to the department. So if you can't get it in, it's fine. But after that, I'm gonna just move on. As far as the exam, I haven't published it yet, but I will today. I'll give you till, I guess. Did we agree upon a time? I don't remember. I don't want to change it on you.
Should we have the same amount of time that we had for the first test? If that's okay.
How much time did you have? Do you remember?
I remember you added time, but I forgot.
Okay. Yeah, right now it's just 90 minutes. So I can give
I
you
think it
more
was
time.
120 total.
Yeah, something like that.
Yeah, I'll throw 120 in. That's fine. That way you can double check yourself.
And it's due Sunday at midnight?
Yeah, I think that's what I'm going to do. August 18th at midnight.
Did you say August?
October, sorry. I don't know if I did. Let's see here. Okay, October 18th, published. All right. So it's currently published. So if you want to take it tonight, you can. I'm not saying you should, but you can. I guess if you have no other questions, you're welcome to head out. And